Thank you for taking a few minutes to learn about Criteria Labs, a space, RF products, and engineering services company. I'm Joe Swoboda. I'm the Vice President of Sales, Marketing, and Customer Success, and I'll lead you through our introduction today. Today, we'll talk a little bit about Criteria Labs, our background, our capabilities, and our certifications. We'll dig into a case study for a space-qualified variable gain amplifier, some of the challenges and how we work through them. We'll introduce you to some of our space-qualified parts. We'll leave you with our contact information so that we connect and work together in the future. Criteria Labs is an engineering services company with deep expertise in the RF and microwave technologies. Today, we'll show you how we solve some of the most complex technical problems, compress schedules, and complement internal engineering teams. Some of our capabilities include GaN and gas eutectic die attach, chip and wire assembly, ceramic space qualified packaging, upscreening, and space and military qualification up to 50 gigahertz. We understand the difficulties in these projects, and we believe no other company can deliver the end-to-end solutions with the quality that Criteria Labs can do. One important factor in delivering space-qualified solutions is that you have the processes and the quality requirements in place to effectively deliver. We're certified in ISO, MIL 38535 for monolithic packaging, and 883 for qualification. We've been sponsored by NASA JPL for 38534 Class K hybrid microcircuits, and we'll complete it this year. We've begun our process for AS 9100 and expect to continue to expand our capabilities going forward. Earlier, we mentioned that we offer end-to-end solutions. The semiconductor market is flush with die, and we typically leverage die from any manufacturer to create our products, including Qorvo, Cree, Analog Devices, Mini Circuits, and others. We can fully design the RF part with basic input-output specifications. And we can work with internal engineering teams to optimize the manufacturability. We assemble the parts in-house in our Class 100 clean room with full test capability. We can leverage commercial off-the-shelf packaging. We can also custom design our own packaging. We have wafer probe capability, 50 gigahertz RF test, and general electrical test capabilities as well. And we have 5 different reliability test labs for full environmental tests to JDEC, NASA, and military standards. We have the largest tape and reel facility in the US, and we've developed a line of space-qualified parts by leveraging off-the-shelf die or by specifically trying to fill obsolescence issues that our customers go through. We also have the capability to design and manufacture integrated microwave assemblies. Next, we'll talk about a 25 gigahertz space-qualified variable gain amplifier. We'll talk about how this is a space-qualified solution and how we went through the custom packaging and verification process to meet all of the requirements. Now, in this variable gain amplifier, the customer's requirement was a variable gain amplifier, 20 to 25 gigahertz frequency range. There was no monolithic solution on the market that had all the requirements for this project. So this became a multi-chip module design project. Required plus 15 dBm, 1 dB compression point, and also had some demanding circuit performance requiring a space-qualified part in a very limited implementation area. Required 38534 and 883 screening. And Criteria Labs, we specifically had to go through and try to leverage die that was common in the design of this project for this specific customer. You can see in this diagram a look at one of the creative solutions that we came to offering this customer a method to prototype and test this prototype early in their design. On the right-hand side, you can see somewhat of a block layout of the different components, including amplifiers, landing pads, capacitors, couplers, power detector, and a variable voltage attenuator. On the left, you'll actually see a printed circuit board design for a custom package laid out with organic materials. Now, when the customer came to us and required a space-qualified packaged part, well, we knew that the custom package was going to require 20 weeks or more to deliver. And we needed to get parts in the customer's hands quickly. So one of our creative solutions was design an organic package for the interim where we could lay all the die out using epoxy And we could fabricate this using readily available organic materials in the open marketplace. We did so, and we were able to develop this custom package and deliver them packaged prototype parts in weeks. Next, we really had to revise the overall design of the part. The input return loss was a critical parameter for this customer, and therefore we really had to quantify and understand the first die in the incoming path of this package. This part was an amplifier, and if you move to the data sheet of the part, in this graph in the center of the screen, you'll see that the input return loss was about -12 dB. That was about where the customer could accept that input return loss. And this became a real challenge because there wasn't a lot of headroom in the design. Now, in this case, what we did is we probed the die by leveraging our in-house 50 gigahertz network analyzer and some probes that we had designed with one of our probe suppliers. We probed the die and quantified the real performance across multiple die so that we had some statistical analysis. And then we analyzed some of the off-the-shelf packages, ceramic space qualified packages that were available in the market. What we recognized is that these packages would not meet the requirement. The matching required was a little bit too difficult for existing off-the-shelf packages, and there wasn't enough headroom in the design. So we partnered with Kyocera, who does create custom packages. In probing the die, we were able to offer solutions on what we required, and we were able to experiment with some of the packages that were readily available. We were able to provide data and test results to Kyocera, who was able to simulate package modifications in their modeling environment. We were able to really identify kind of the bathtub of what we needed of the input return loss, which you can see here in the center of the screen, and exactly where we needed it centered for the customer's requirement. In doing so, we could offer a matching solution that would meet the requirements that ultimately the customer required. You can see some of the modifications we came up with was better ground castellations, that changed the ceramic wall, moved from standard wire bonds to ribbon bonding, and also moving to a better matched printed circuit board with improved grounding as well. We're able to simulate all these characteristics by partnering with a leader in the industry for packaging. The result was a package that met the desired RF requirements and was able to be tested with through lines and input terminated lines before we even began building the part. You can see here a drawing of what some of the end part resulted, the results of some of the end part. We were able to package the part, and if you look at the circuit performance area, you can notice that many of these die are very close together. And it took a lot of precision work in order to make sure that we could die attach these effectively using the appropriate materials and assuring that they would be space qualifiable in the future. And this custom design really met that requirement. In addition, we were able to hit the input return loss requirements, and the entire signal chain was a significant reduction, down to a 7x7 QFN for pick and place capability for the customer's end design. And this is a really important milestone in this project, as it resulted in size, weight, and power savings, as well as key RF performance requirements. Now, over the years, many of the things that we have learned at Criteria Labs have led us to really understanding what it takes to make space qualified parts and making sure that they can perform in the harshest environments, including space as well as military. They're also able to perform in oil and gas environments. We've developed our line of space qualified gain blocks. They are self-biasing in a small package up to 12 gigahertz in frequency range. And we leverage off-the-shelf die from analog devices, mini circuits, and a few others. They have in-gap P-hemp transistors targeting typically SATCOM and radar applications, although they can be used just about any application. In addition, we have a line of GaN power amplifiers that leverage our eutectic void-free die attach process with void-free gold tin die attach and hermetically sealed ceramic QFN packages up to 30 gigahertz. Our MCM and hybrid designs leverage a similar packaging concept. It allows us to really scale how we build space qualified parts across multiple types of applications. We know this package works well, and we're able to leverage the design from our GaN power amplifiers over to our MCMs. This part is a limiter and an LNA up to 20 gigahertz with 17 dB of gain and 2 dB of noise figure. We're also nearing release for our first solid state power amplifier, Ka band downlink, targeting 17 gigahertz to 21 gigahertz. This is a high power added efficiency design, specifically optimized for the downlink transmit signal chain of a satellite. This part's PAE is over 50% for reduced power consumption or for better loading more channels into fewer signal change. This optimized design can help really optimize the overall satellite transmission design. Our expert sales team at Criteria Labs has over 90 years of experience in the RF and semiconductor space. Please sign up for our newsletter and contact us to discuss your most difficult project requirements. Thank you for your time today. Really appreciated speaking with all of you.